AI is, well, it's everywhere, right? But the language, the jargon around it, it's changing so fast it's almost impossible to keep up. So in this quick explainer, we're going to lean on Dr. K's research to break down the core terms you really need to know right now.
I mean, you've probably seen these terms splashed all over the headlines. They are, for sure, the building blocks of this whole AI boom. But what do they actually mean? Let's dive in and get some answers.
Seriously, AI's everywhere. I think my toothbrush just got an AI update. That's how crazy things are getting. So our goal here is simple: to give you a solid handle on the core ideas pushing this whole revolution forward. Let's decode this language together.
Okay, so here's our game plan. First, we're going to talk about the brain of modern AI, the large language model. Then, we'll get into the big breakthrough that made all of this possible. After that, we'll look at the toolkit that's making AI even smarter. And finally, we'll peek over the horizon to see what the future of intelligence might look like.
All right, let's start with part one, the so-called brain of modern AI. You know, to really understand what's going on today, you have to get a grip on this one concept, the large language model, or LLM. It's truly the foundation for everything else we're going to talk about.
So what is an LLM really? When you strip it all down, it's basically a super sophisticated mathematical function that's just incredibly good at one thing: predicting the next word in a sentence. That's it. When you're chatting with an AI, it's just predicting the next most likely word over and over again to build out its response.
Okay, but what makes a large language model large? Well, it's numbers like this: 175 billion. That's how many parameters are in a model like GPT-3. Think of a parameter as a tiny little knob that the model can adjust as it's learning. And when you have 175 billion of those knobs to tune, yeah, it can learn some incredibly complex stuff.
And the amount of data it learns from, it's just as mind-blowing. Let me put it this way. If you tried to read all the text GPT-3 was trained on, reading around the clock, 24/7, it would take you more than 2,600 times years. That's the kind of scale we're dealing with here. It's just wild.
So when you boil it all down, the recipe for building an LLM has three key ingredients. First, you need a massive amount of data: books, articles, the web, you name it. Second, you need a very specific design called a transformer architecture. And third, you need a training process where the model just practices predicting the next word over and over, literally trillions of times.
And that brings us perfectly into our second section, the breakthrough. You remember that transformer architecture we just mentioned? Well, it turns out that T in something like GPT, that's not just a letter. It's the absolute game changer, the key that unlocked everything we're seeing in AI today.
And this really gets to the heart of why it was such a big deal. See, before transformers came along in 2017, models had to read text one word at a time, in order. It was so slow. But transformers, they changed everything by looking at all the words in a sentence at the exact same time in parallel. All of a sudden, training on those massive data sets we talked about became possible.
So how in the world do they do that? Well, it's all thanks to this brilliant idea called the attention mechanism. This is really the secret sauce. It's a way for every single word in a sentence to kind of talk to every other word. This lets the model figure out which words are important to which other words, so it can truly understand the context.
Yeah, and this quote really nails it. The attention block is all about figuring out which words are relevant to other words. It's how a model knows that the word bank in riverbank is totally different from bank in investment bank. It's not just looking at the word bank in isolation, it's paying attention to the words around it.
Okay, so you've got this incredibly powerful brain, this LLM built on a transformer. Now what? What can you actually do with it? Well, that's where the toolkit comes in. Think of these as powerful add-ons that take a basic LLM and give it superpowers to do some really useful real-world stuff.
First up, we've got agentic AI. And this is a huge leap from a simple chatbot that just answers your questions. An AI agent can actually work towards a goal all by itself. It runs in this constant loop. It looks at what's going on, it thinks about the best thing to do next, it does that thing, and then it sees what happened. Perceive, reason, act, observe, over and over.
So what does that look like in the real world? Well, imagine an AI agent acting as your personal travel agent, actually going out and booking the flights and hotels for you. Or maybe it's a data analyst digging through reports to find important trends. It could even be a DevOps engineer that finds bugs in the code and fixes them all on its own.
All right, next up in the toolkit is something called RAG.
That stands for Retrieval Augmented Generation. This is a super clever way to solve one of the biggest headaches with LLMs, the fact that they can just make stuff up. They hallucinate. That's because their knowledge is stuck in the past. RAG is like giving the AI an open book test. It lets it look up fresh, up-to-date information before it gives you an answer. This makes it way more reliable, especially for professional work.
Here's a quick breakdown of how it works. So, you ask a question. The RAG system doesn't just send that to the LLM. First, it goes and searches a database for relevant info. Say your company's latest HR policies. It grabs that information, adds it to your original question, and then gives the whole package to the LLM. What you get back is an answer that's actually fact-checked and informed.
Okay, so we've talked about the brain, the breakthrough, and the toolkit. For our last section, let's look to the horizon. Let's talk about the future of intelligence, or at least the theoretical future.
First, you hear this term a lot, AGI, or Artificial General Intelligence. This is the idea, the hypothetical goal of an AI that can perform pretty much any mental task as well as a human expert could. And I really have to stress this part. AGI is purely theoretical right now. We are not there yet. It does not exist today.
And then, if you take it one giant leap further, you get to ASI, Artificial Superintelligence. Now, this is a theoretical AI that would have an intellect that just dwarfs the smartest human minds. And a really key idea here is something called recursive self-improvement. This is the concept that an ASI could start upgrading itself, getting smarter and smarter, potentially at an exponential rate.
And that, of course, leads to the biggest question of all, right? Could an ASI solve humanity's greatest problems? Cure disease and poverty? Or could it create entirely new problems that we can't even imagine? It's a pretty profound question, and it's why ASI is a term you're going to want to keep on your radar.
Okay, so let's wrap this up with the key takeaways. Remember, LLMs are basically super powerful next word predictors. The transformer, with its attention mechanism, was the absolute key breakthrough. Tools like agents and RAG are giving these LLMs all sorts of new powers. And finally, AGI and ASI, that's the theoretical future we're all watching. So, that was a quick, high-level flyover of some of the most important concepts in AI today. We've really only scratched the surface here. If you want to go deeper and see more detailed examples and how these models work in practice, you should definitely check out Dr. K's full presentation on the topic. Thanks so much for watching.